Hello, everyone. This is Naveen Mareddy. I work as a software engineer, senior software engineer at Netflix. So I'm from the Media Cloud Engineering group. We handle everything like large-scale compute and storage for transcoding the main playables on the product, clips, trailers, images. All of this is handled by our group. The infrastructure for that is powered by our group. So I work in a team which does a compute and storage team. We call it a CSI. So I'm from that group. So I'm going to show you how we are enabled our video engineers in doing media innovation and kind of taking out a lot of this large-scale cloud things away and abstract all of it and make it possible so that they can innovate quickly. So with that, first, I'll show you with some use cases, which is where the innovation, the recent examples that our users have done. So I'll pick a few recent examples, and let's see what they've done. So first one is the artwork for the Billboard user experience. This is the main page that you land when you land in the Netflix product page. The main page that you see, the images required, the artwork that is needed for that experience is to pick the best images, which has high dynamic range and also the right positioning so that we can place text and all that properly. There's an algorithm that is run to find these high definition images. So that innovation feeds into something called there's another thing called a Netflix media database. So all the innovations happening in getting the deep technical metadata about the media is all maintained in something called as Netflix media database. So I'm calling out one of those aspects, which is for the artwork. So here's how it looks like. So this is like a mock visualization of the Billboard user experience on the product. So this image, to do that experience, we have to find an image which has a place to put the text, and in this case, left side, and then the main actor on the right. So there are some CV and ML algorithms that are running, which are finding this picture from the stream. And here are the hints that are highlighted by the algorithm. Similarly, one more here, which is from the chef table. Again, here, this is the product experience, which is powered by the hints that are provided by the algorithms. So this experience we powered by our platform, which I'm going to talk next. Second use case is picking the episodic stills. When you're browsing any episodes in the Netflix product, the artwork, the box art for every episode, picking those images. For that, there's an internal user group which use our platform. They built an application called as Ava. So one of the this is the Ava tool, which is used internally. This is a screenshot from that. There's multiple steps involved in finding best episodic stills. One of those steps involves finding the best images. So this is a screenshot of that, which we're powering. And third use case is even in subtitle authoring. This is a subtitle authoring tool to enable the authors. In this tool, as you can see in the bottom, there's the green lines, which are the short changes in the video, which are highlighted in the tool. So this helps the subtitle authors to place the text such a way that properly around the short change boundaries so that it is easy for the users to read the subtitles. So these are just to touch few. I called out like 3 use cases. These are only no means exhaustive. There are only very few of them that are called out here. Now, how do we do it? So we created a platform like about 1.5, close to 2 years ago. Internally, we call it as Archer. So what is Archer? Like we created this platform which is highly kind of opinionated, serverless, MapReduce style media innovation platform, which is used by all our users to do all these beautiful innovations in minutes. So the rest part of the presentation, I'll show you high level how we're doing it. Before that, I'll show you some numbers from some of our applications. So last year, like our users have used 100 million plus compute hours on Archer platform for a variety of innovation use cases. And the Ava tool that I've shown the second use case before, Ava tool has processed about 13 billion video frames on the Archer platform. Also, like coming to text, also even text use cases where detecting text, like 2 billion instances of text in the video frames were detected by using the smart ML recipes running on the innovation platform. Coming to pure text, this is a pure text use case where there are about 770 million dialogues from 73 different languages which were analyzed for TTML research and for optimal subtitle placement on the videos. So 120 million short change events were detected by various kind of ML recipes running on the Archer platform. So now how all of this is happening, to give a quick glimpse into how this is happening at Netflix. So I'll take you through a very simple use case that every one of you should be familiar with. And our team is more into infrastructure. We partner very closely with the encoding technologies group at Netflix, who are the audio, video, text specification experts. We work very closely and partner with them to do all this work. And I'll show you example of how a small grayscale clip generation looks like, and then slowly show how it looks like in Archer platform. So to generate a grayscale clip, what do we need? Like a color input clip, then process each frame in this input, and then apply the grayscale recipe, and finally create the output clip. Looks simple. If you were to run it, like people generally start by running it on the whole media, by scaling it and thinking of the scale when you're starting with the recipe, don't come naturally. But in Archer, we've given some constructs, some hints, so that users, if they build the recipe in a certain way, then it goes very well for the parallelization and cloud ready, basically. So let's see how that happens. So step one, we ask our users. So by the way, this is the user perspective of what a user goes through. So step one is when the source is given, the user should should split this source into splits. So like a split 1 through n here, let's say like every 2 seconds, a split. And then process the frames, apply the grayscale recipe on each split, producing the split prime. Similarly, apply on every split. Then, after all the splits are processed, now they're all in grayscale version now, just concatenate all the splits as a final step and to produce a final full grayscale clip. In this experience, from all the steps, imagine if user were to just write the red script part, that's it, once. All other things are taken care for the user from the platform. They're like all opinionated concepts which exist where users can express. I want to split this video by time duration every 2 seconds, which already exists. They don't have to write anything for that. Or they can even say that I want to split this video by shots. So then we go get the short metadata and split the video. So the users don't have to write any code to do that kind of splitting. So effectively, this use case of creating grayscale clip can be done by just writing the grayscale recipe once. What that looks like, a sample FFmpeg command. Don't quote me on this. This is like sample command here, which I want to call out the input and output aspect of it. The recipe is this one. I just picked one recipe here. So the important things are highlighted here in red. The input is a directory which our Archer platform already makes available for the users. So by the time the script is invoked, the frames are already available for that split in the input directory. Then also the output directory is predefined and set up so that users just drop their output to that location and rest is all handled. So this is what runs for every split. Now let's turn around and see what is the all heavy lifting that we are doing in the Archer platform behind the scenes, which is making it so smooth and simple. So with this, I'll show the other side of the coin, which is from the platform standpoint. So when the split phase comes in, the platform jumps in, and if user picked default built-in functions, then we have that code, we get that code in and then do the splitting. And also the platform goes and picks the movie source from the cloud, also the metadata about the movie. Like if we were to split it by shot, then where is the shot metadata? All of that is abstracted for the users. So that red part there is done by the platform if most of the use cases people pick built-in splitters. Next thing, before running the script, the blue arrow here, which is where we download the frames for that split ahead of running the split. Then we run the actual program. And also, the Archer is polyglot friendly. When people are innovating, generally, they want to use like scripted languages like Python, or even any other just shell scripts, or someone may just do Java. So we support all this polyglot environment. We run that script. Then the output produced by the script, we go watch the output in the output directory shown by the red arrow here and upload it to the cloud. Then finally, when all the splits are done, the platform monitors that state, that whether all the splits are finished, and then concatenates all of them into one final clip. Again, concatenation of all the splits to one final output is also a predefined recipe. Users don't have to write anything for this. I just say that I want to use concat split collector, or they want to use zip collector. Also, it's very common that more common functions like in the split or collect, we see a pattern where users were contributing into Archer. Like a short-based splitter was like a thing developed by one of our users and contributed into the platform. So that way we keep this ecosystem like live so that it makes more reuse friendly. Now, just to recap what it looks like, simply we just, there are three phases: split the media, and then map. This is where mostly we run the user code, and then the collect. So users can even write all three custom functions if they don't want to use what platform provides. Now with this, I'll show you we'll get into more. I'll show you more details on like what happens when a job is submitted and how the execution goes through. Before that, I used the word serverless computing before. So this is the definition of serverless computing from Wikipedia. I'll just read it out. Serverless computing is a cloud computing execution model in which the cloud providers act as the server, dynamically managing the allocation of machines. So this is a very fundamental thing that we use in Archer, where servers are not visible. The infrastructure is invisible to the users. It's all serverless, so that once a request is submitted, whatever they do for one request or for like thousands of them, it all looks same. There's no server that they have to log in and watch what is going on. So that's what we base on here. And we use containers. So the recipe for the map, especially for the map, the users can write in a Docker file and submit it as a Docker image, and then we run it at scale. So which means the users can bring in a brewing FFmpeg, like a forked version of FFmpeg, or any image magic, or any tools they want, and without thinking about what version they're going to get in the cloud. So whatever works locally works in the cloud. Here is how a typical job execution looks like, purely from the backend perspective, like a systems diagram. The user normally submit a job request. This job request is like a REST API where the request contains the movie against which the recipe has to run. Here also we did a deep integration with the Netflix catalog, which means if anyone want to run an algorithm on a particular movie or a trailer, they can just give the ID of that trailer from the catalog without knowing about where they're exactly saved in the cloud. So in the REST API request, that will be one part, the inputs, and then the recipe they want to use, and then the Docker image, which has to be used for running this algorithm. Then we accept the request, and we start an instance in our workflow engine. The workflow engine has like predefined workflow for this MapReduce execution. So the moment a request comes in, then the workflow first determines what needs to be done. Like, did we run a split on this? No. So then we just go ahead and run the split on top of it. Then from the split, produces like multiple maps. Then it runs all the maps. Once all the maps are done, then it makes a determination to run collect. It's basically a state machine which uses a data store to keep track of where this particular job request is in now. As part of running the workflow, at every stage, like split phase, map phase, and collect phase, at every phase, the workflow engine sends the messages into the queues. I've intentionally picked the different color queues here. Every application, every function has different queue. So the messages go into the different queues for asynchronous execution. Then in response to the messages in the queue, we have, this is where the serverless aspect comes in. Elastically scaling compute cloud is listening on these messages in the queue on respective queues, which is where we pick in the Docker image supplied by the user and hook it to the queue from the application of the user. So on top of this, we have a queue-aware scaler, which monitors the backlog in individual queues and then scales the application worker pool for that particular queue. This is how, if there's with having all these millions of CPU hours, like a small recipe or prototyping can happen like in minutes, actually. Like if there is a movie which has like 1,000 clips, 1,000 splits, if we have 1,000 containers running, then they'll all finish like in a few seconds. And the platform is built for the media, which means like content security is another aspect. Very early on, we were given every user should just think about content security, or can we bake it into the platform? Since when we're working on this recipe, sometimes we work on pre-release content, which is very sensitive. So all the content security dimensions, aspects around the content, inputs and outputs, the temporary outputs, they're all handled by the platform. So users don't have to worry about auditing or the keys for managing the content. Also rapid prototyping. Since we use Docker, the local machine experience is all Docker, and then in the cloud also the same Docker image is used. So users can quickly run, make an algorithm, test it on one split, and then push to the cloud and modify and iterate quickly. And large cloud I/O, this is one big thing, which is where I say proudly that media-ready platform. Since by years of experience working in the transcoding group on our team, we know how to handle the large media files. Generally, all the source contents are generally in orders of half terabyte or in that order. So downloading the sources in the cloud from so many splits in parallel, there are a lot of things we learned over the period. All those learnings are offered as transparently to the users in the Archer platform. So what we do is we use a fuse-based mounting software where we mount the frames into the container, and it's kind of lazy downloading. We don't download the frames up front. So we just make all the frames available locally as if the remote frames mounted locally. And as the encoder starts reading the frames, we do a prefetch and keep reading. So if you want to know more about this, we're doing a small demo about this. We call it internally Mesafast in our Netflix booth. I can go over that demo. And also, we capture compute usage metering. This is also being very helpful. Whenever anyone runs an experiment or a production use case, for every job or even for a whole application, there's nice metering reports where user can see how much compute hours were spent for certain experiment, and then they can make a determination whether to run it at scale or compare with the previous generation of the algorithm by seeing how many compute hours were used. And towards the end of the presentation now. So these are some of the recent Netflix tech blogs. We blogged about Archer in June. There are more details and some other extra use cases that we talked about in blog post. Even Netflix Media Database, this blog dropped this week actually, which this media database has all deep technical metadata about movies. Most of this is powered by Archer. They use Archer for extracting that rich metadata from the movies. That's it. Thank you. You can hit me.